So pause and copy. So this one, I'm going to go through it step by step. I have lots of zeros, so the 4x4 is not going to be so bad as we see. And we'll also come up with a useful pattern, which we'll use later on. Okay, so I'll start with I'm going to start with the first column. Cofactor expansion down the first column, so I get 3 times the remaining determinant and that's it. Now what? I'll leave that 3 out front, and I'll do a cofactor expansion again down the first column. Minus 2, 1, 5, 0, 2. I'm going to leave these two numbers factored because it will show me in the next step a nice pattern. So I have a 2 by 2, so I just do AD minus BC, giving me 1 times 2, so A times D. So, what happened? We had, to begin with, what's called a triangular matrix. Okay, what that meant. So a triangular matrix is one in which you have strictly zeros below the diagonal or strictly zeros above the diagonal. So if you have a triangular matrix, then what turns out to be the case is that the determinant is just the product of these diagonal entries. You'll notice how the diagonal entries here are appearing at the end there. Okay, so we'll write this down as a theorem. So the determinant of a triangular matrix is the product of the diagonal entries. Okay, so triangular can be, in this case, this is called an upper triangular matrix because it has non-zero entries above. And then you also have what's called a lower triangular matrix where you have kind of transpose, where you have non-zero entries appearing below the diagonal. So, but those are both called triangular matrices. And to find the determinant of such things, we just take the